Welcome. Today we're diving into the world of General Motors transmissions and exploring a critical question that many GM owners face: whether an external transmission cooler is a worthwhile investment for your vehicle. General Motors produces some of the most widely used automatic transmissions in the automotive industry. From the reliable 4L60E to the modern 10-speed automatics, these transmissions power millions of vehicles on the road today. These transmissions are complex mechanical systems with hundreds of moving parts, clutches, and planetary gear sets. All of this complexity generates heat during operation, and managing that heat is crucial for transmission longevity. Transmission fluid serves as both a lubricant and a coolant, but it can only do so much. When temperatures rise beyond optimal levels, the fluid begins to break down, leading to reduced performance and potentially catastrophic transmission failure. This brings us to our central question: can an external transmission cooler help protect your GM transmission? Throughout this series, we'll examine the benefits, potential drawbacks, and real-world applications to help you make an informed decision. Whether you're towing heavy loads, driving in extreme conditions, or simply want to maximize your transmission's lifespan, understanding cooling options is essential. We'll provide you with the knowledge to make the right choice for your specific GM transmission and driving needs. Automatic transmission fluid, or ATF, is truly the lifeblood of your transmission system. This specialized fluid performs three critical functions that keep your transmission operating smoothly and efficiently. First, ATF provides essential lubrication, reducing friction between the countless moving parts inside your transmission. Second, it creates the hydraulic pressure needed for smooth gear shifting. Third, and most importantly for our discussion, it helps dissipate heat generated during operation. To understand how ATF works, let's look at the internal structure of an automatic transmission. This cutaway view shows the complex arrangement of gears, clutches, and hydraulic passages where ATF circulates continuously. The most critical aspect of ATF performance is maintaining the correct operating temperature. The ideal temperature range for automatic transmission fluid is between 175 and 225 degrees Fahrenheit, or 80 to 107 degrees Celsius. Temperature directly affects ATF condition and performance. This fluid color chart shows how ATF changes as it degrades from heat exposure. Fresh ATF is bright red, but as temperatures exceed the ideal range, the fluid darkens and loses its protective properties. Many vehicles don't come with transmission temperature gauges from the factory, but monitoring ATF temperature is crucial for transmission health. When temperatures exceed 225 degrees Fahrenheit, ATF begins to break down rapidly, leading to reduced lubrication and potential transmission damage. Understanding ATF's role as both a lubricant and coolant helps explain why external transmission coolers can be beneficial. By maintaining optimal fluid temperature, we preserve ATF's ability to protect transmission components and ensure smooth, reliable operation for years to come. Automatic transmissions are complex mechanical systems that naturally generate heat during operation. Understanding why transmissions overheat is crucial for maintaining your GM vehicle's transmission health. The primary source of heat in automatic transmissions comes from friction. The torque converter uses fluid coupling to transfer power from the engine, creating friction and heat as the impeller and turbine interact through transmission fluid. Additional heat comes from clutch packs and planetary gears inside the transmission. These components engage and disengage constantly during shifting, creating friction that converts mechanical energy into heat. Under normal driving conditions, transmissions operate within acceptable temperature ranges. However, certain driving conditions dramatically increase heat production beyond the transmission's ability to dissipate it effectively. Towing heavy loads forces the transmission to work much harder. The torque converter stays unlocked more often, clutches engage more frequently, and the entire system operates under increased stress, generating significantly more heat. Aggressive driving behaviors like rapid acceleration, hard braking, and frequent gear changes also increase heat generation. Racing, mountain driving, and stop-and-go traffic all contribute to elevated transmission temperatures. When transmissions overheat, the automatic transmission fluid begins to break down. This degradation has serious consequences for transmission performance and longevity. Excessive heat causes the transmission fluid to oxidize and form varnish deposits. You can see here how clean fluid becomes dark and contaminated when exposed to high temperatures over time. As the fluid degrades, it loses its ability to lubricate moving parts effectively. This leads to increased friction, more heat generation, and accelerated wear of transmission components. The consequences of transmission overheating are serious and costly. Here are the warning signs that indicate your transmission fluid has been damaged by excessive heat. These symptoms indicate that overheating has already caused damage to your transmission. Prevention through proper cooling is far more cost-effective than repair or replacement after overheating occurs. A transmission cooler is fundamentally a heat exchanger designed specifically to remove excess heat from automatic transmission fluid. Understanding how this process works is essential for maintaining optimal transmission performance. The heat exchange process works through thermal transfer. Hot transmission fluid flows through internal passages while air flows across external fins, carrying away heat and reducing the fluid temperature. Most vehicles come equipped with an integrated transmission cooler built into the radiator. This system uses the engine's cooling system to help regulate transmission fluid temperature. An external transmission cooler adds supplemental cooling capacity beyond the integrated radiator system. This creates a two-stage cooling process for enhanced heat dissipation. The cooling capacity increases significantly with an external cooler. While a radiator-only system might maintain fluid at 200 degrees Fahrenheit, adding an external cooler can reduce temperatures to 175 degrees or lower. External coolers are especially beneficial during demanding conditions such as towing, hauling heavy loads, or performance driving. These situations generate additional heat that can overwhelm the standard cooling system. External transmission coolers come in two main types, each with distinct designs and performance characteristics. Understanding these differences helps you choose the right cooler for your specific needs. The first type is the tube and fin cooler. This is the more traditional and economical design, featuring aluminum tubes arranged in an S pattern with cooling fins attached over the tubes. Tube and fin coolers are less expensive to manufacture and easier to build. The transmission fluid flows through the aluminum tubes while air passes over the external fins to dissipate heat. The second type is the stacked plate cooler, which offers superior cooling performance. In this design, the fins themselves form the passages for fluid flow, similar to how a car radiator works. Stacked plate coolers are more efficient because the fins form the actual fluid passages. This creates more surface area for heat transfer and allows for better cooling performance compared to tube and fin designs. When comparing performance, stacked plate coolers consistently outperform tube and fin designs. The improved heat transfer efficiency makes them the preferred choice for demanding applications, despite their higher cost. Understanding these two cooler types helps you make an informed decision. While tube and fin coolers offer cost savings, stacked plate coolers provide superior cooling performance for applications where maximum heat dissipation is critical. External transmission coolers provide several critical benefits for your GM transmission. The most important benefit is dramatically extending transmission life by preventing the fluid degradation that occurs when temperatures get too high. When transmission fluid operates within the optimal temperature range of 175 to 200 degrees Fahrenheit, it can provide maximum protection and performance. However, even small increases above this range can dramatically reduce transmission lifespan. External transmission coolers help maintain consistent performance by keeping fluid temperatures in the optimal range, even under demanding conditions like towing or performance driving. The cooling system works by routing hot transmission fluid through an external heat exchanger before returning it to the transmission. This additional cooling capacity prevents overheating during heavy use. External coolers are particularly beneficial for towing applications, where transmission temperatures can rise above the normal range. They help prevent the costly transmission failures that can occur from sustained high temperatures. By keeping transmission fluid temperatures in the optimal range, external coolers can significantly extend the life of your GM transmission and maintain reliable performance for years to come. While external transmission coolers offer benefits, they also come with potential drawbacks that must be carefully considered before installation. The first major concern is overcooling, especially in cold climates. When transmission fluid becomes too cold, it thickens and can cause delayed or harsh shifting, reducing fuel efficiency and driving comfort. Cold transmission fluid leads to delayed engagement, harsh shifting, and reduced fuel economy as the transmission struggles to operate efficiently with thickened fluid. Improper installation is another significant concern. Poor workmanship can lead to fluid leaks, damaged seals, and even catastrophic line failures that can destroy the transmission. Perhaps most importantly, external transmission coolers cannot solve existing internal transmission problems. Worn clutches, seal failures, and valve body issues require internal repair, not additional cooling. Before installing an external transmission cooler, carefully weigh your climate conditions, vehicle usage, installation quality, and cost versus benefit. A thorough analysis ensures you make the right decision for your specific situation. Climate plays a crucial role in transmission cooling decisions. Different temperatures create unique challenges that must be addressed for optimal transmission performance. In cold climates, external transmission coolers can actually cause problems. When transmission fluid becomes too cold, it thickens significantly, leading to poor shifting performance and reduced efficiency. To understand why temperature matters so much, let's examine how fluid viscosity changes with temperature. This graph shows the dramatic relationship between temperature and fluid thickness. The solution to this problem is a thermostatic transmission cooler. This intelligent system uses a bypass valve that only activates the external cooler when the fluid reaches optimal operating temperature. When the transmission fluid is cold, the bypass valve directs most fluid around the cooler, allowing rapid warm-up. Once the fluid reaches the proper temperature, the valve closes and forces all fluid through the cooler for optimal heat dissipation. A leading example of this technology is the thermostatic adapter from Improved Racing, launched in 2022. This adapter is specifically designed for GM's 6L, 8L, and 10L transmissions. This adapter activates at 160 degrees Fahrenheit, ensuring the transmission reaches proper operating temperature before engaging the external cooler. This prevents the shifting problems and efficiency losses associated with overcooling. For cold climate operation, a thermostatic transmission cooler is essential. It provides the benefits of external cooling when needed, while preventing the problems of overcooling during cold weather operation. Proper installation of an external transmission cooler is absolutely critical for both performance and reliability. Poor installation can lead to costly leaks, reduced cooling efficiency, and even transmission damage. Installation success depends on following these critical steps. Each step is essential for preventing the most common installation failures that can damage your transmission. This diagram shows the typical installation points for a transmission cooler system. Notice how the cooler connects to the transmission through dedicated lines, and proper routing is essential for both function and clearance. The decision between professional and DIY installation depends on several factors. Professional installation is recommended for complex routing, high-performance applications, or when you lack experience with hydraulic fittings. Bowler Transmissions has announced a significant advancement in transmission cooler installation with their new line manifolds. These are specifically designed for GM's 6, 8, and 10-speed automatic transmissions. The manifold uses -6 AN size fittings, which provide a secure, leak-resistant connection. This sizing chart shows the relationship between AN and NPT fittings, helping ensure proper compatibility during installation. The angled fitting design provides significant advantages over traditional installations. By aligning with the bell housing geometry, the manifold keeps cooler lines tight against the transmission case, providing better clearance and reducing the risk of damage from road debris or maintenance activities. Whether using traditional fittings or advanced manifold designs like Bowler's innovation, remember that proper installation prevents costly failures. Always test your installation for leaks before putting the vehicle back into service. Proper fluid type and maintenance are critical for transmission longevity. General Motors specifies exact fluid requirements for each transmission model, and following these specifications is essential for optimal performance. The choice between synthetic and conventional transmission fluid significantly impacts performance. Synthetic fluids offer superior heat resistance, better lubrication properties, and longer service intervals compared to conventional fluids. Regular fluid inspection is essential for transmission health. Check the fluid level using the dipstick when the engine is warm and running. The fluid should be between the minimum and maximum marks on the dipstick. Fluid condition is equally important as fluid level. The color, smell, and consistency of transmission fluid reveal its health. Fresh fluid should be bright red and have a sweet smell, while degraded fluid appears dark brown or black. General Motors recommends specific maintenance intervals for transmission fluid changes. Severe driving conditions such as towing, stop-and-go traffic, or extreme temperatures require more frequent service intervals to maintain optimal transmission performance. Proper fluid maintenance extends transmission life significantly. Using the correct GM-specified fluid type, maintaining proper levels, and following recommended service intervals are the foundation of transmission longevity and reliable performance. Many newer General Motors vehicles come with factory-installed transmission cooling solutions, especially those equipped with towing packages. Understanding what your vehicle already has can save you time and money. Factory transmission coolers are typically included in towing packages and heavy-duty applications. These systems are designed and tested by GM engineers to work seamlessly with your specific transmission model. One common integration method is mounting the transmission cooler within or alongside the air conditioning condenser. This placement provides excellent airflow while maintaining a clean factory appearance. To determine if your GM vehicle has a factory transmission cooler, check your vehicle identification number specifications, owner's manual, or look for additional cooling lines running to the front of the vehicle. Understanding the difference between factory and aftermarket solutions helps you make informed decisions. Factory systems are integrated and warrantied, while aftermarket options offer more customization but require careful installation. Before adding an aftermarket cooler, always verify whether your GM vehicle already has factory cooling provisions. This knowledge ensures you make the most cost-effective and appropriate cooling solution for your specific needs. The aftermarket transmission cooler industry offers numerous upgrade options specifically designed for popular General Motors vehicles. These solutions provide enhanced cooling performance beyond factory specifications. Popular General Motors models like the Chevrolet Silverado and GMC Sierra are prime candidates for aftermarket transmission cooler upgrades due to their frequent use in towing and heavy-duty applications. Aftermarket transmission cooler kits typically include all necessary components for installation. A complete kit contains the cooler unit, transmission lines, fittings, mounting brackets, and detailed installation instructions. Here we can see a real-world installation example. This vehicle has both an aftermarket transmission cooler mounted in front of the radiator, along with an additional smaller cooler below it for maximum cooling capacity. This technical diagram shows how aftermarket coolers integrate with the existing cooling system. The cooler connects to the transmission via high-pressure lines and is positioned for optimal airflow through the radiator assembly. This installation shows the upgrade process in action. The new silver transmission cooler is mounted in front of an older black unit, demonstrating how aftermarket options can enhance or replace existing cooling systems with improved performance. Aftermarket transmission cooler kits offer several advantages over factory options. They provide enhanced cooling capacity, convenient all-in-one installation packages, and often cost less than original equipment replacements while delivering superior performance. The automotive community is divided when it comes to external transmission coolers. Expert opinions vary significantly, creating an ongoing debate about their effectiveness and necessity. On one side, pro-cooler experts emphasize the significant benefits. They argue that external coolers extend transmission life by maintaining optimal fluid temperatures and preventing the heat damage that leads to costly repairs. However, anti-cooler experts raise serious concerns about reliability and effectiveness. A transmission shop manager explains that they often steer customers away from aftermarket coolers due to persistent problems. Real-world evidence supports both sides of this debate. Technical diagrams show the complexity of cooler installations with multiple connection points that can potentially fail. Critics point to common failure modes, such as leaks at connection points. This image shows exactly what transmission shop managers warn about: fluid seepage that can lead to costly repairs and environmental concerns. Another major concern is the fragility of cooler components. Aluminum fins are easily damaged and require careful maintenance. Bent or broken fins significantly reduce cooling efficiency. Professional mechanics often express skepticism based on years of experience. They've seen too many cooler-related problems to recommend them universally, preferring to address cooling issues through proper maintenance and driving habits. This debate highlights the importance of considering multiple expert perspectives before making modifications to your transmission system. Both sides present valid concerns that vehicle owners must carefully weigh. Traditional transmission coolers have a significant limitation. They can overcool transmission fluid in cold weather, causing shifting problems and reduced efficiency. Modern thermostatic control systems solve this critical issue. Thermostatic control adapters represent a major breakthrough in transmission cooling technology. These intelligent devices automatically bypass the external cooler when fluid temperatures are too low, ensuring optimal operating conditions. The relationship between temperature and fluid viscosity is critical for transmission performance. As this graph shows, transmission fluid becomes too thick when cold, making it difficult for the transmission to shift properly. Here's how thermostatic control works in practice. When the transmission fluid is cold, the thermostatic valve keeps the bypass open, allowing fluid to circulate directly back to the transmission without going through the cooler. Once the transmission fluid reaches the optimal operating temperature, typically around 175 degrees Fahrenheit, the thermostatic valve automatically closes the bypass and directs fluid through the external cooler for proper heat management. Recent developments include advanced thermostatic adapters specifically designed for GM's modern transmissions. Companies like Improved Racing introduced thermostatic adapters for GM 6L, 8L, and 10L transmissions in 2022, representing the latest in cooling technology. Thermostatic control represents a significant advancement in transmission cooling technology, particularly beneficial for vehicles operating in colder climates, where traditional coolers can cause more harm than good. Modern transmission cooler technology has evolved significantly from older designs. Today's advanced coolers offer superior performance through innovative engineering approaches. Traditional tube and fin coolers have been the standard for decades. These coolers use aluminum tubes arranged in an S pattern with fins placed over them to dissipate heat. Modern stacked plate coolers represent a significant advancement. These designs feature fins that form the actual passages for fluid flow, similar to automotive radiators, creating much more efficient heat transfer. The key advantage lies in the heat transfer efficiency. Stacked plate designs can achieve up to 40% better cooling performance while using significantly less space and weight. Real-world examples demonstrate these improvements. Modern coolers feature sophisticated internal structures with optimized fin designs and fluid pathways that maximize surface area contact. These design improvements translate to practical benefits: smaller installation footprint, reduced weight for better fuel economy, and superior cooling performance that extends transmission life significantly. The evolution from tube and fin to stacked plate technology represents a significant step forward in transmission cooling efficiency, offering GM vehicle owners better protection and performance. Towing applications represent one of the most demanding scenarios for vehicle transmissions. When a truck pulls a heavy trailer, the transmission must work significantly harder than normal driving conditions. During towing, transmission temperatures can rise dramatically. Normal operating temperatures of 175 to 200 degrees Fahrenheit can quickly climb to 250 degrees or higher under heavy load conditions. Towing places multiple stress factors on the transmission. The increased torque demand, extended high load operation, and frequent gear shifting all contribute to excessive heat generation that can damage internal components. An external transmission cooler provides the additional heat dissipation needed for towing applications. The cooler can reduce fluid temperatures by 50 to 100 degrees Fahrenheit, preventing overheating and protecting the transmission during demanding conditions. Consider a pickup truck towing an 8,000-pound trailer. Without an external cooler, transmission temperatures can exceed 260 degrees Fahrenheit, risking damage. With a properly sized external cooler, temperatures remain in the safe 180 to 200 degree range, ensuring reliable operation and long-term protection. Performance vehicles present unique challenges for transmission cooling. Modified engines and aggressive driving conditions generate significantly more heat than standard applications. High-performance engines with turbochargers, superchargers, and modified internals produce substantially more power and heat. This increased thermal load directly affects transmission fluid temperatures. Track days, racing, and aggressive street driving create demanding conditions. Sustained high RPM operation and frequent gear changes generate continuous heat that can overwhelm standard cooling systems. Without adequate cooling, performance vehicles experience fluid degradation, inconsistent shift quality, and potential transmission failure during critical moments. External transmission coolers provide the additional heat dissipation needed for performance applications. They maintain optimal fluid temperatures even under extreme conditions. Proper fluid routing ensures maximum cooling efficiency. Performance applications often use dedicated cooling circuits, separate from the radiator, to maintain consistent temperatures. Performance vehicle owners report significant improvements in transmission reliability and longevity after installing external coolers. The investment pays dividends in reduced maintenance costs and enhanced driving confidence. For serious performance enthusiasts, an external transmission cooler is essential equipment. It ensures your transmission can handle the demands of high-performance driving while maintaining reliability and longevity. While external transmission coolers offer significant benefits, many vehicle owners have legitimate concerns about potential leaks and component failures. Understanding these risks and how to minimize them is crucial for making an informed decision. The cooling system diagram shows multiple connection points where leaks can potentially occur. Each junction, fitting, and hose represents a potential failure point that requires careful attention during installation and maintenance. This engine diagnostic diagram illustrates various failure modes that can occur in automotive systems. Similar issues can affect transmission cooler installations, including external leakage, component deterioration, and connection failures. Proper installation is the first line of defense against leaks and failures. This includes using the correct torque specifications, ensuring clean connection surfaces, and following manufacturer guidelines for routing and securing transmission lines. High-quality components are essential for long-term reliability. This means using transmission coolers from reputable manufacturers, premium hoses rated for transmission fluid, and proper fittings that won't corrode or fail under pressure. Regular inspection is crucial for early detection of potential problems. Check for signs of fluid leaks, examine hose condition for cracks or swelling, ensure all connections remain tight, and verify that protective shields are intact. Protection from road debris is often overlooked, but critically important. Install protective shields around the cooler, route lines away from potential impact zones, and consider using protective sleeves on exposed hoses to prevent damage from rocks and debris. By following proper installation procedures, using quality components, maintaining regular inspection schedules, and protecting against road debris, the risks of leaks and failures can be significantly minimized, making external transmission coolers a reliable upgrade for your GM vehicle. Choosing whether to install an external transmission cooler for your GM transmission requires careful consideration of several key factors. The The right decision depends on your specific situation and needs. The first and most important factor is your vehicle usage. If you frequently tow trailers, haul heavy loads, or engage in performance driving, an external cooler becomes a worthwhile investment to protect your transmission. Climate is equally crucial. In cold weather regions, transmission fluid can become too thick if overcooled, causing shifting problems. This is why thermostatic coolers are essential in colder climates. Finally, consider your budget for both the initial purchase and professional installation. While coolers can extend transmission life, weigh the costs against your vehicle's value and expected lifespan. Let's look at a practical decision framework. This flowchart will help you determine if an external cooler is right for your specific situation. If you regularly tow trailers or haul heavy loads, an external cooler is strongly recommended. The extra heat generated during these activities can quickly damage your transmission without proper cooling. If you don't tow regularly, consider whether you engage in performance driving or live in a particularly hot climate. These conditions can also benefit from additional cooling capacity. Climate considerations are particularly important. Cold weather can cause transmission fluid to thicken, and an external cooler without proper controls can make this worse. A thermostatic bypass valve automatically routes fluid around the cooler when temperatures are low, allowing proper warm-up. Once the fluid reaches operating temperature, it flows through the cooler for heat dissipation. Different vehicles and usage patterns require different cooler capacities. This selection guide helps match the right cooler to your specific vehicle and towing needs. Remember that proper installation is crucial for any external cooler. Poor installation can lead to leaks, pressure problems, or inadequate cooling. Consider professional installation if you're not experienced with transmission work. The right choice for your GM transmission depends on balancing these factors with your specific needs and budget. When in doubt, consult with a transmission specialist who can evaluate your particular situation and recommend the best solution. External transmission coolers represent a significant investment in your GM vehicle's longevity. When properly selected, installed, and maintained, they can dramatically extend your transmission's operational life. The key to maximizing transmission life lies in understanding 4 critical factors: proper cooling system design, appropriate cooler selection, professional installation, and consistent maintenance practices. Proper fluid routing is essential for effective cooling. The transmission fluid must flow through the radiator first for initial cooling, then through the external cooler for additional heat dissipation before returning to the transmission. Selecting the right cooler size is crucial for your specific vehicle and usage. Different vehicle types and towing capacities require different cooler specifications to achieve optimal performance and longevity. Regular maintenance remains the cornerstone of transmission longevity. Even with the best external cooler, neglecting fluid changes, filter replacements, and system inspections will ultimately lead to premature transmission failure. When all factors align, proper cooler selection, professional installation, and diligent maintenance, an external transmission cooler becomes a powerful tool for extending your GM transmission's life. The investment in cooling technology today can save thousands in transmission replacement costs tomorrow.